Thanks, everyone. It's my first time attending Flutter London. I can see we have a nice community here. I say first time not because I don't want to attend it. I live in Manchester. But today that Tide is hosting this event, I figured it would be a nice excuse for myself to attend it for the first time. So my presentation will be about debugging issues that are beyond the code that you already own, so issues in external dependencies. But first, let me introduce myself. So I'm a senior mobile engineer at Tide. I'm a Flutter developer. My background before Flutter was .NET, and now I'm planning to learn Kotlin multi-platform. I think it's also a pretty cool stack. And so Tide is a fintech platform. We offer many financial services to small and medium companies. We operate in the UK, India, Germany, and France. So it's services such as getting a business current account or loans and other services that might be useful for small and medium companies. And this is where you can find me. There will be links at the end. So first I'm going to talk about what we'll be talking today and who this might be for and who this might not be for. So the first part, we're going to be debugging a very interesting bug that was reported to us 2 years ago. This was a time before AI. It's a bit scary to debug at that time. But I hope this can also be refreshing because we're trying to learn from things that happened before this AI era. And the second part, if you read the description of this meeting, we contributed this fix to Flutter. But we're going to talk about the different approaches that we considered and how you can apply these different approaches in other libraries and other frameworks. So we're going to try to make this general, but we're going to use an example for this specific bug that affected Flutter. And the last part is going to be my opinion. This is going to be a reflection on the current state of Flutter and what it means to contribute to Flutter today. It's, again, going to be based on my experiences. So it's going to be very opinionated. Going back to the app that we developed at Tide, we developed a very large app to over 2 million customers worldwide in many languages and many devices. And when you push Flutter to this scale, you end up finding many bugs. And sometimes these bugs live outside of your code base, which means that we are affected by bugs that we don't directly control, but we can suffer from their consequences, which means that we need to do something about them. And this scale comes with its own challenges, and this is one of them. So, for example, if you have a bug that you rarely see, a bug that affects 1% of devices, it means that when you are scaling to 2 million people, you are affecting thousands of users, even though it might seem like a small bug. I'm going to try and move the cursor out of the way. Okay. So the bug that we are talking about today had an internal code name. It's a very professional code name. It's called the weird stretchy bug. And you're going to find out why we call this name internally. Here's a quick recording of a video reported by QA. So when we were filling the details at the sign-up page, the end result was a very stretched state of the page. And this is not a blocking bug. The user could still proceed, but being a first experience of the user, this has a high reputational value to the customer. We don't want to break their experience on the first screen that they see. And I'm part of the onboarding team, and we look after the first experience of the user with the company. Let me try and summarize this issue. So this is the initial state, and then when they type their mobile number and they transition back to the initial state, they end up with a very stretched version of the page. So this is what we're talking about. And notice that when we're focused on this field, there's a very small scrollable part just under the bottom bit. And this small bit is going to be related to the issue later. But first, we tried to debug this issue in many devices using many engineers. We asked many engineers in our community if they had experienced it firsthand, and no one was able to reproduce it. We inspected the state management. We even tried a build with impeller on and without impeller on, see if that's affected it somehow. But no, we were not able to reproduce this bug. So we did what every engineer does when there's only one report of a bug, and it works on my machine. We did not close it, but we put it on the back burner. We were thinking about it, and if we had another report, we would open it again. And yeah, soon after that, I would say maybe a week later, we had another report, and this one from an engineer inside our community. And after this, we took things seriously, and we went back to the drawing board, and we tried to understand what is it that we know about this bug. So we know that 2 people saw it in an Android device. It might be Android related, it might not be Android related. And this page, a little bit of a description. Every custom widget that you see in this page is stateless. The only stateful widgets are from the design system library that we use. And for this reason, we figured that a stateless widget, such as a simple text, would not probably cause a stretch effect. So we decided to investigate the design system library, and it's always easier to blame Dan's team. Dan looked after the design system team. So we were trying to find a culprit in this library. And this was our focus. But we quickly reached a dead end. We don't have any custom scrolling effects or stretching effects in the design system library. What we do have is some components appear different in iOS and Android, and this could explain why we could only see this issue in Android. So for example, when we want to show a loading spinner, in iOS we show the Cupertino one, and when we want to show it in Android, we show the material one. And this is just an example of the differences of the design system in the 2 platforms. So having this in mind, we had this theory that maybe this stretch effect could be due to something that we call an overscroll indicator. So when you're scrolling on an app, you want to give feedback to the user that they've reached the end of the page. And in Material 2, this is represented by a glowing indicator to say that there's nothing more to show. Whereas on Material 3, it's a stretching effect. And how is this related? Well, we figured that the design system team had enabled the Material 3 widgets just a few weeks before the first bug was reported. So this was our main suspect. But how could we be so sure that this was causing the issue? And so far, we had different suspects. First, we thought that it only affected our sign-up feature at the outer layer. We usually work with features that are in this outer layer, and then the medium layer, we have something like utilities. We've got state management utilities, we've got auto route, we've got the design system inside. And then we realized that maybe this bug could live in the core of the stack in Flutter. So this was our visual chain of trying to find where this bug lives. And now we suspect that it lives in Flutter in the material effect for Material 3. But the only way that we can be sure that this is in Flutter is if we are able to reproduce this outside of our app. And for this, when we raise an issue with an open source project, we usually produce something that's called the... Oh, not yet, I'm getting ahead of myself. So before we want to debug an external dependency, we need to make sure that the IDE has the right settings enabled. And this is something that's, I think, disabled by default, which is ensuring that the breakpoints outside the main app get triggered when you're trying to debug it, which is somewhere in your IDE, but also in VS Code. You can see it at the bottom as this indicator when you've got debugging your code, packages, and I think there's another one for the SDK. And if you're thinking about raising an issue with a big, large open source project, it's very likely it has contribution guidelines. You should read them. This presentation is not going to cover what the Flutter contribution guidelines are, but it's a very good piece of documentation maintained by our community, our Flutter community. Yeah, so going back to the material 3 overscroll indicator, this is the name of the widget in Flutter. And I'm going to try to digest this into small bits. So we've got a widget. It would be good if this worked. OK, yeah. So we've got a small widget. And the stretch factor comes from this stretch controller. If we are ending with a very stretched state, it's very likely that the bug comes from the controller. And here we can see the actual stretch effect being applied. It's essentially the stretch factor, either X or Y, if it's a horizontal scroll or vertical scroll, and it stretches the children. So this is what happens when you see this effect in Material 3. Now, if we look at stretch controller, there are two types of animations, or two types of handlers, let's say. One, when the user is manually pulling and dragging along the page, and the other one, when the page is scrolling by an event. So for example, when we change the keyboard, like we saw in the demo before, this is an event-triggered overscroll, and this is the method where that would be having this issue. And the important thing here is to understand the variables involved in this, and one of it is velocity. And we can see that this might feel a bit overwhelming, but if we digest it, we see that velocity is between 1 and 1,000. So if it's less than 1, it defaults to 1. If it's more than 10,000, sorry, it defaults to 10,000. And then there is a duration that depends on this velocity. And it took me a while to realize that the bug might be here. But essentially, if the velocity is small enough, let's say 24, then this is going to round to 0. And the question that I have to yourself is, what should an animation with no duration do? Because this can be a little bit meta, like what do we expect Flutter to render when there's an animation with 0 milliseconds? And for this bug, I'm not trying to fix that. I'm not trying to change the Flutter behavior on rendering animations. But if there is a requirement that there should be an animation overscroll, we need to set a limit duration, because a 0 milliseconds animation does not make much sense. So this was the starting point for trying to fix this bug. And once this was applied, so here we're just taking, let's say, 50 milliseconds as a minimum duration, we think that this might fix the bug. But how can we be so sure? There is something called a minimal reproducible code. This is incentivized when you're raising an issue to a large product, or really any project. And essentially, you try to reproduce the issue with as little code as possible. It doesn't need to be clean code. It just be understandable code that someone with a different stack than you can understand. And in this, we can start from a blank Flutter app. So you should be familiar with the counter example that we have when we create a new Flutter app. And for this one, I decided to have our single child scroller view. And if we're running in Material 3, it will default to this effect. And there is a square container. Why square? Because if we want to communicate that there is a stretch bug, we can easily tell that a rectangle is not a square. And there's also two text form fields, one that accepts email address and the other phone. Why? Because there's these two types of keyboards, the alphanumeric and the numeric one, have different heights. And this means that when it scrolls, this small difference in height might trigger a low velocity. And so you need to get a little bit creative to reproduce a bug that's very hard to reproduce, because there are so many variables involved. But when you do it, so here I'm just focusing between different fields. And here is the demo I submitted to the issue raised. I'm just setting keyboard height so I can communicate to the maintainers how you can reproduce this bug. You can very easily see that this bug is reproducible in a simple Flutter application. So we could be very sure now that this bug existed in Flutter. And if we apply this fix in the SDK and I run it again, many, many times, I can no longer reproduce the issue. And this is a very good indicator that the bug lived there and that this simple one-line fix fixed the bug. After raising this issue, it got triaged by the community, and it got accepted as an issue, and then comes on collaborating on creating a fix. And as part of this fix, we also had to create a regression test. And for the regression test, I noticed that there are multiple ways to reproduce this bug, actually. Another one of them, if you get more creative, is to create a fake environment with a high drag when you scroll. And a high drag means that your velocity is going to be very, very low. And this means that you can reproduce the bug in a test, and then you can assert that when it's fixed, the stretch effect no longer applies. But yeah, this is just to demonstrate that there are multiple ways to reproduce a bug that might seem irreproducible. You just need to get creative sometimes. And then when you are working on the fix, there are multiple approaches you can take. One way is to do a dirty fix and just copy the bad code, put it in your code base, and fix it yourself. This has a few advantages. It means you don't need to wait for maintainers. It means that you control everything. But controlling everything means that you will also need to maintain this code from now on, and things might break in the future. And this here probably is around 300 lines that we had to maintain. It's not something we want to maintain forever. But this is just an example. We copy the bad widgets, we fix them in the code, and then we apply a fixed scroll behavior in the entire app. And then another approach we could have taken, and this is something we consider, was forking Flutter and fixing there ourselves. And this might make sense for some cases, we'll talk about that later. But it is a slippery slope in the sense that every time that we disagree with the direction of Flutter, we change the Flutter framework, and then we need to update the CI/CD, and we are essentially forking away from the default framework. And then the last approach, which is the more ethical one, is to work with the maintainers and contribute a fix that everyone is happy with. And for example, this is an oversimplification. This is essentially what the fix was. There was a little bit more to the regression test and constants for defining this minimum duration. But this means that in the long term, you don't need to worry about owning this code because the maintainers now maintain this code for you. It also means that you can update without worrying of breaking anything or not benefiting from updates in the material design system. However, there are some downgrades. It can take a while to contribute to a large project, especially when there are many maintainers involved. And there's a high bar of entry for these submissions, which we'll talk about later. So if we compare these three approaches, the first one being the dirty fix, it's very easy, but then your effort of maintaining it might increase over time because you are maintaining this additional code in your code base, and things might break, tech debt might pile up. The second one is a soft fork. It's relatively easy to fork. You need to change the CI/CD, yeah, but then you need to merge every update and resolve merge conflicts. And the last one is contributing the fix. And this takes a lot of effort initially because we need to work with the maintainers, but eventually we no longer need to put any effort because that's part of the framework. And there is no single right choice. It depends on the project that you're contributing to. For example, if the project is no longer maintained, it doesn't make sense to even try to contribute to it. If your contribution does not align with the maintainer's view, it also doesn't make sense to contribute to it. So approach B might be valid in some approaches, approach A might be valid in some approaches. What we ended up taking for this one was a mix of A and C. A, because we wanted this bug fixed as soon as possible. So we were happy with maintaining these 300 lines for the short term, but we worked with the Flutter team to contribute this fix and update when ready. So several months later, we managed to get this landed in Flutter. And yeah, our small contribution was no longer affecting users in our app and in other apps as well. Is it not triggering? I think it's... Okay. And now we're entering the part 3. This is going to be my opinion and my experiences as a contributor to Flutter and as a contributor to other open source projects. I've contributed to Flutter a few times, not many times, but essentially, we think that Flutter is open source. In my opinion, it is not really an open source project. Yes, the code is available, but there is a big player behind it, And there is a big disclaimer. I totally appreciate the Flutter maintainers. I appreciate the Google engineers who work there. The critiques here will be towards the big institution behind it and not to the people involved in here. So it's about the corporate procedures around maintaining open source projects and how they can deter people from contributing to these projects. So first one is one that's very common in large projects. It's a contract that you need to sign before actually being able to contribute to these projects. And this is very, very intimidating for small contributors. And no one understands these legal documents because we're not lawyers, but this can very easily intimidate people from contributing. Essentially, it's protecting Google from you contributing copyrights software into their domain so they don't take liability from that. You are attesting that you own this code. But it also introduces a few things that are a little bit more controversial. For example, if this was a copyleft project, which meant that it needs to be redistributed with the same license, it means that Google can get away with that without having to comply with those terms. So Google could redistribute your code in proprietary software if they wanted. They didn't need to make it public. If they wanted to, stop maintaining Flutter, but still maintain an internal fork of Flutter and distribute that themselves, they would be able to distribute your code forever and they would not need to pay any royalties to you. And they also have the patent rights. So patent rights. Even if you contribute to Flutter, Google can make patents on the name of your contributions. So this is something that most open source purists say that is not an open source value. But then Flutter has a big issue. Well, it has many issues. We know that there's many open issues on GitHub, but one thing that I found while contributing is that there are many, many more issues that we don't even know existed. So for example, this issue that we contributed, that we raised for the first time, allegedly, was already known to Google. When I contributed the fix, I saw that Google testing was failing, and they already had a regression test that captured the very extremely stretched state, and that was the test that was failing. So they already knew this issue existed internally, and it was just never disclosed to the public. So this poses the question of how many issues Flutter has that are not disclosed to us, and how that could not reflect the spirit of an open source project. And this aside, it's very hard to contribute to Flutter because every small change, even a one-line change, can break these internal tests that you don't have control of. They're closed source tests, and that means that sometimes you contribute something that might be fine, but then it might get reverted because it is breaking their tests. And you're expecting something to land in a release, and it doesn't land in a release, it misses a release. So ultimately, there's a closed source set of tests that have requirements that you don't know about. And this has some implications. For example, I guess we'll talk about this later. Why should you care that this is not really an open source project? Well, if you're attending this meeting, you're probably related to Flutter at some point. You probably have some interest in its success in the future. But having a big company behind it, having a big company behind it that might just kill the project if they want to, puts our careers at risk and our ambitions at risk and the project itself at risk. So Google does not have a great track record for maintaining projects. They sometimes kill very successful projects. There's a lovely page called Killed by Google, and there's many projects in there. I think Angular might be in there. The point that I'm trying to make is that there's massive source of issues that are private, that we don't know, that have a lot of valuable information, and if Google ever decides to stop maintaining Flutter, we are going to lose all this precious knowledge, and this is going to make maintaining Flutter as a community. So if Google stops being a maintainer and we want to maintain it ourselves, it's going to be way more difficult without all this knowledge that will be lost. So yeah, I ramble a lot about this, and this is because of my frustration that this example here, it took a lot of effort to debug it. The fix was very easy. It was just one line. But if we knew that the issue already existed, it would be much easier. Sorry, this did not animate. there you go. Yeah, it would be much easier to have debugged this issue if it had been made public in the first place. But this doesn't mean that this is the end and this is like a terrible project. Flutter is taking the right steps right now, and there are a few examples. One way, there is a community version of Flutter, a community fork. It's called Flock. And as much as I like this idea, it's easier said than done. It's very hard to maintain a fork of Flutter. So right now there's 20 PRs, which is barely a fork, but it's still a very great initiative, and maybe it will have some legs someday. I hope so. But even the Flutter maintained by Google is taking steps in the right direction. For example, you might have heard that they're trying to move the Material and Cupertino design systems outside of Flutter. This is because Material has always been a first-class citizen in Flutter, and Cupertino has been left behind. And this is a good step in decentralizing Flutter, making Flutter less dependent on Google. And this means that contributing to Flutter when there's a Material issue should not block your PR like we saw before. And there's another company joining in. You might have heard that Ubuntu have applications in Flutter desktop now, and it's been recently announced that they are the lead maintainer for Flutter on desktop. And this is something we appreciate, because it means that someone else is also taking the lead on maintaining a very big part of Flutter. So we are taking steps in the right direction, but what would the ideal future of Flutter be? And I think it's easy to see what this would be. We just need to look at the competitor, which is React. Recently, React ownership moved from Meta to its own foundation, the React Foundation. It's an organization within the Linux Foundation. I think it's a not-for-profit, but essentially what this means is that there's a governing body of different companies that contribute to the future of React. And this is very important for stability of a project long-term, because it's not a single company that's behind the funding of a big project. So before we spoke about why you should care about this, and now we're talking about why now. I mean, Flutter has been like this for many years, and my opinion is that Flutter is on a very unbalanced battle, is an uphill battle against React right now, because we've got AI, and AI models are heavily trained on React and JavaScript frameworks. So most people these days are using AI to find about new frameworks, and it's not very likely that AI will just teach them about Flutter or talk to them, tell them how to build a Flutter app, because they've been trained on JavaScript frameworks. Yeah, I think this is the end of the presentation. It was built with Anti-Gravity IDE and Gemini. It was made with SlideF, which is a framework in JavaScript. And this is where you can find the source code for this presentation, if you want to inspect the links or how it was built. I don't know if we are going to do Q&A now or later. Yeah. Does anyone have any questions?
Yeah, I have one. Thinking about how much time your company spent on this issue that you were trying to solve, I'm curious, like, if you think about it in two parts, how much time did you spend on the workaround that you spoke about implementing the quick fix? So this is probably like implementation plus maintaining it over time, versus how much time you put into collaborating in terms of getting the fix into the Flutter framework itself. So that could also be like time spent in the actual discussion thread, resolving tests failing, all that kind of stuff.
That's a very good question, because Flutter maintainers are very collaborative. Even if you don't get things right from the first contribution, they can very easily teach you how to get there. And yeah, they're very helpful, and we didn't lose much time with them. The only time that we lost was really in having them fix these internal tests that were closed source and that we couldn't fix ourselves. And in terms of how much time we lost for the quick fix, not a lot, which is why we did that quick fix initially. We spent about, I would say, 1 to 2 weeks debugging this bug, and that's a few engineers involved, which it's probably a lot of time. It would have made our lives easier if it had been made public in the first place.
Okay, thanks.
Did this answer?
Yeah, I mean, your typical typical route with bug investigation, right? Most of the time is spent on the investigation and tracking it down.
Yeah, this is why this bug was so interesting, because rarely you find a bug that can have such a big impact and have such an easy fix. And that's why it is elegant for a small presentation. In my opinion, I'm a bit biased. Yeah, any more questions?
Any further questions?
Okay.
Right. Well, thank you, Gil.
Yeah, one more thing. So if you believe that these issues could be made public, then you can talk about them and release the Flutter files. Just speak with your peers and maybe build a better Flutter community, because it's up to us to push for that. Okay, that's the end.
Thank you.